Welcome back to Student Tutorials. In this video, we're going to be looking at the first of the two scripts you're going to need for the wireless transfer of data between your two ESPs. And we're going to start with the sender script. Now, of the two scripts, this is by far the hardest and the longest one to understand. But the next one is very quick to do, so don't be put off by the amount of work this one might be. Anyway, let's first recap what we need to do to actually get this working in this script. Well, number one, we have to find the MAC address of the ESP that we're going to be sending the data to. Now, we've already done that. We did that in the video before, so we've done that. Okay. The next thing is we have to create a packet which will store all the data we need. I'm going to come back in a second to about that point. Number three, we have to define a function that will be run when the data we have sent and received. So we have to define a callback function that essentially, when we send the data to the other ESP, the function is then ran and it sends a message back confirming that what we have sent has been received. And again, like I said, imagine a ball being me throwing a ball to someone and then I'm saying I caught the ball. This is what we're doing here. We then have to actually establish a connection to the other ESP. So we have to define how we're going to connect to it and what address we're going to connect to it with. And finally, we have to send the data to that ESP. Okay, so coming back to that packet point, what is a packet? Well, a packet is a formatted unit of data that generally contains two things: control information and user data. The control information consists generally of a lot of different information, but there's two important bits that we're going to need, at least for this simple model of a wireless network. We're going to need an address of where we're sending the packet to, and we're going to need the address of where it's come from. And in this case, they're both going to be MAC addresses. A good way to think about this is imagine you're writing a letter. So you write your letter on your bit of paper, and what you write is your data, your user data. Then at the top of the letter, you put the address you sent it from and the date. That's the address where it's come from. And then you put it in an envelope, and in front of the envelope, you put the address of where you're sending it to. This is very similar to what we're doing here, so it's a good way to think about it. Okay, now we're actually going to get into looking at the code. Now, it is quite long, and if you haven't done C++ or programming much before, you might struggle to understand the syntax, but that's not the point of this video. I'm not going to show you a general case that you can then use to program everything. I'm showing you and I'm explaining the code so that you can understand what's happening. But if you don't totally understand what's happening, that's okay. Okay, let's get into it. So, first thing you need to do is we need to define that broadcast address that you obtained in the last video, the MAC address. And so I've just put this in an array. I've put my address in an array. Each bit of the address occupies its own unit of the array. And I've just called it broadcast address. Okay, now we need to actually define how our data is going to be sent, how it's going to be structured. Now, you could just send each of your variables from the temperature sensors separately to the receiving ESP, but that would take a lot longer, and it would mean that you're going to have to send data many, many times. So instead, we can do something quite clever. We can create what's called a structure. So C++ allows you to do this. A structure is where you can essentially define your own type of variable, and it can have as many parts as you'd like. So normally, you just, I don't know, maybe you'd have an integer, like a variable that's an integer, and you can store a number in it, full stop. But with a structure, you could define a variable with a structure that lets you have a float part, and it lets you have a string part, and it lets you have an integer part, and as many parts as you'd like, you can have in this one variable, and it keeps it all in one. So that's what we're doing here. So I'm type def struct, I'm defining that I want to make a structure, and I'm going to call it struct message. And now we have 3 temperature sensors, so which means we need 3 identification codes, so the names of the temperature sensors, and we need 3 spaces where we can put the data from each of the temperature sensors. So I've done that here. I've defined 3 32-bit chars instead of a string to save space. And then I've defined 3 floats where we'll put the temperature values of it. That's great. That's our structure. And then we're actually going to create a variable with that structure called my data. So that's just me doing it there. So we've essentially created our own data type. That's an easy way to think about it. Okay. This next line here is just me again, giving something else a different name. You can imagine in Python, I'm sure you've done it before, where you can import panda as PD. It makes it easier. It's easier to type out PD than it is panda. That's what we're doing here. We're giving this this variable, which is to do with the ESP-NOW library. We're giving that the name peer-info, so it's a bit easier to access. Okay. Next bit is we have to define our callback function, don't we? So I'm going to define a void function, which means it doesn't return anything, and I'm going to call it onDataSend. And I'm just going to give it two parameters: the MAC address, so the MAC address of where the data is going to, and the status, so how what the status of the operation is. So I'm just going to print the line last packet send status, so I know what we're talking about when I get random information out. And then I have this quite clever line here. I like the fact you can do this in C++. So essentially what it is a conditional statement within a print statement. So I'm saying, essentially, if status is equal to success, so if the ESP-NOW library reports that there was a success in sending the data, then the first option will be printed, delivery success. However, if they are not identical, in other words, if it wasn't a success, then it's going to print delivery fail. And this helps us keep track of what's happening in our code. It's always useful to print messages throughout your code so you know what it's doing. Okay, so that's our callback function made. Pretty easy. Then we go to our setups, so the things we need to set up. Some of the code here is just the same that you will have for your temperature sensors. It's not necessarily to do with the Wi-Fi. Another thing we need to do is we need to tell the ESP that I want it to act as a Wi-Fi station. So again, we can use this line here. I'm just setting Wi-Fi.mode. So here's mode is the method, and I'm setting the mode to Wi-Fi station. That's all I'm doing. Now I have a conditional statement here, but that has a sort of other function. Not only does it check something, it also runs this function here. So when we get to this line, it will actually run this function and at the same time check whether it's true. It's quite a neat thing you can do here. So ESP-NOW init is just initializing ESP-NOW. So we need to run that obviously to start up the operation. And if that runs and the output I get is not equal to ESP-OK, so if it doesn't report that it was OK trying to initialize, then it's going to print this. If it is OK and I do get that message, then it's not going to print anything. It's just going to carry on. Okay, then the next line here, you just have to make sure that you tell the ESP-NOW library that I want this as my callback function. You have to, otherwise it's just not going to do anything with it. Okay, then down here, I'm just setting some of the necessary addresses and things you need to be able to send this data. So this is the peer info variable I gave an easier name to use. So I'm just giving the peer info, so the peer info part of the ESP library, I'm giving it my broadcast address, which is this address up here, so it knows where to send the data. And I'm setting the channel to 0, which is just a channel you're going to want to use for this. There's a few different channels. I'm not actually sure what they do, but that's not relevant. And I'm saying that I don't want to encrypt the data. It's not particularly sensitive data we're sending here, so there's no need to encrypt it. Cool. Now, I've got another one of these cool if statements that runs the function at the same time. But this time, I'm actually giving the ESP-NOW library my peer info information. So I'm giving it all that information I've defined here about my peer, the receiving ESP. And if it takes in that information and it's OK, then it just carries on. But if it's not OK, then it's going to say it's failed to add a peer. It's not been able to establish a connection with the receiving ESP. Great. OK, then that's all the setup done. Now we get to the loop statement. So a lot of this code is, again, just this stuff on the temperature sensors. Cut that out. Until we get to here. Now this is where we actually use that variable my data we've made with the structure, the custom structure. So here I'm just, each of these lines just says, so my data.a, which is one of the characters, I'm going to say that that's equal to T6 temperature in C, so it'll print that every time. And same with Dallas and same with PT1000. And then the next bit, I'm just giving the temperature data here. So if you have a structure with lots of different components, you can access your different components by doing the variable name dot and then the name of the component. So So here I've called them A, B, C, D, E, F for simplicity. You could call them whatever, but that's just what I'm doing here. Okay, now what I'm doing here is I'm saying that I want this variable result to be, let's not do that, linked to the ESP-NOW send function. So when I call the variable result, it will also run that function. And now this is the function that's actually going to send our data. So within that function, we've got a few parameters. We've got to give it our MAC address, which is, again, broadcast address, what we define up here. That's where we're sending it to. We're giving it my data, so the data we're sending. And we're also going to give it the size of my data, so how much storage that data is taking up, how much space it is. And then I've got another one of those if statements here, and it's going to run that function there. It's going to run the ESP-NOW function. And if it's okay, then it's going to say sent with success. And if it's not, it's going to say ever sending the data. Great. Okay. So that's all the code. So now we're going to try uploading it to the ESP-NOW and see if it actually works. Obviously, I've not got the other end done yet, so it won't be able to send any data, but you should see ever sending the data if it isn't able to. So let that compile. It can take quite a while with ESPs. You see it's uploading, going to different memory locations. And there it's done. So if we open a serial monitor, we'll see it's been able to send it, but that it's not been received, which is exactly what we'd expect, that the other ESP isn't even plugged in, let alone programmed yet. So that's great. Anyway, that's the script for this, for the sending, and that's what we're going to cover in this video. In the next video, we're going to look at the receiving script, and then from there, we'll actually do a demonstration of this working, so you can see it working. Thanks for watching.